Very good morning, my dear friends and channel viewers. Myself, Dr. M.H. Annaya, and in today's video, we are going to work out a problem on a curved beam, that is a crane hook having trapezoidal section. The question for today's video reads like this. For the crane hook shown in figure, the figure is given to us. Determine the load the crane hook can take. The load, whatever they say, is that load P. What is the load the crane hook can lift by limiting the maximum tensile stress to 117.39 Newton per mm square. Friends, here all the dimensions of the cross section, like the cross section at the inner fiber B, which you call it as BI, that is BI is equal to 90. The cross section at the outer fiber is called B naught. B naught is equal to 25 mm. This is the outer fiber A, inner fiber B. And friends, you know very well the maximum stress in a curved beam, that is in a crane hook what you have taken, irrespective of the cross section of the crane hook, it happens at the inner fiber. That is, maximum stress occurs at the inner fiber B. C is the center of curvature, which is given to be 65 millimeter. And friends, they are asking you what is the maximum capacity or what is the load, the maximum load the crane hook can lift by limiting the maximum stress in the cross section to this 117. Friends, you have to commence the problem by stating that in a crane hook, the maximum tensile stress occurs at the inner fiber and its value is given by the formula sigma I at B. B means the inner fiber is equal to sigma direct plus sigma bending at the inner fiber. Sigma direct plus sigma B. You have to start from here. So they have given us what is the sigma I at B, that is 117.39 is the value of stress is equal to sigma direct. You know very well, for any cross section of the beam, the direct stress is P by A, load over area of cross section, load divided by area, and the sigma BI, it is positive at the inner fiber, and that is given by the formula MBCI divided by AERI. Friends, we can rewrite this formula as P by A plus MB is P into RC, the formula for MB, CI divided by AERI, AE into RI. These are values. So, the area can be found out because we have the cross section and we have a formula to find out. This MB is equal to P into RC. So MB will be in terms of the load. Direct stress also in terms of the load. So if you are able to calculate RC, CI, RI and eccentricity, we will be able to find out what is the value of load or what is the capacity of the crane hook. Friends, for this, we will have to find out what are these various parameters such as the value of CI, etc. Friends, what in all the problems on crane hook, you have to find out that the value of CI. So we'll start from there. CI is equal to Rn minus Ri. So friends, you should know the value of Rn. Only when you know Rn, you can find out the value of CI. So friends, for the for trapezoidal section, trapezoidal cross section, comma we have Rn given by the formula h by 2 bi plus b naught, that is in other words the area, divided by bi r naught minus b naught ri by h ln of r naught by ri minus bi minus b naught. A very big formula. This is available in the machine design data handbook under this chapter, curved beams. Friends, let us see what are these values. Friends, if you see the diagram, bi is equal to 90 mm, b naught is equal to 25 mm. The value of h, the width of the section is 116 mm, and we want Ri. Ri is given to be 65 millimeter, and the value of R naught, the distance of the outer fiber from here, that is Ri plus h, that is 116 plus h, this is h, and that is 65 R. So this will be 181 millimeter. So friends, make a substitution of all these and the value of this Rn works out to 103.4873. This is 103.4583 millimeter. This is the value of Rn. So Rn, friends, lies somewhere here. This is Rn. Rn is the distance from the neutral axis to the center of curvature C. Then friends, you have to find out the value of Ci. So Ci can be found out now. Therefore friends, Ci is equal to 103.458, that is Rn minus Ra is 65. So this works out to 38.4583 mm. So we did not find out the value of this C naught because we don't need them. Ri we know. E friends is the eccentricity. It is Rc minus Rn. Friends, Rc you will have to find out. So to find out Rc, you need to know the center of gravity of the cross section, or CG. Say it is somewhere here, friends. This is our G, center of gravity, and we will call this distance as x bar from here, x bar from the inner fiber. So RC is the distance from G to the center of curvature C, center of gravity, center of curvature. So it is nothing but Ri plus x bar. So friends, the value of RC is equal to Ri plus x bar. So Ri is 65. X bar you have to find out. What is x bar? Because the cross section is symmetrical about this line. So the location of CG of that for a trapezoidal section is given by the formula h by 3 bi plus twice b naught divided by bi plus b naught. This is available in MDH. Friends, h is 116, bi is 90 plus 2 times b naught. B naught is 25, you can see here, divided by 90 plus 25. Friends, this value of x bar works out to 47.07 mm. Therefore, the value of RC will become Ri plus x bar, 47.07. That works out to RC equal to 112.07, 112. 0.07. So friends, value of E will be RC minus RN. The value of RC is 112.07 minus RN value 103.4583, and if you simplify the E works out to 8.6117. So we have got all the parameters of the cross section for substitution in the formula. So friends, now we will substitute these values here and get what is the load the member can withstand. So to make the concept clear, I will rewrite this last step. Sigma I at B, the inner fiber, is sigma tensile, that is equal to 117.37, 117.39, sorry, 39 is given to be so much. That is equal to sigma direct plus sigma BI. So sigma direct is P by A plus MB CI divided by AE RI. So that is equal to P is unknown to be found out. Area of the cross section is the formula half the height into sum of the parallel sides, BI plus B naught, plus MB is P into RC, the radius of curvature RC, multiplied by CI divided by area, again H by 2 BI plus B naught. You can have this calculation made separately and then you can substitute also E into RI. So friends, here P is unknown, H is 116 by 2, BI is 90, B naught is 25. This is one term, that is sigma direct, plus P is unknown. The value of RC we have calculated as 112.07 into CI value 38.4583, 38.4583, P into E into RI is 65, sorry, CI divided by AERI. Area is same, 116 by 2, 90 plus 25. Eccentricity is 8.6117. 8.6117 multiplied by Ri is 65. And on the left hand side you have got 117.39. Friends, if you simplify this, you get this P is equal to 90,000 is equal to 90,000 Newton, or P is equal to 90 kilonewton. That is the maximum load the crane hook can lift. Any value up to that only this cross section will be able to lift. Friends, if you compare this with a previous video on the same cross section, same question was asked when the load was given as 90,000. We got the stress at the inner fiber as 117.39. So if you go through these two videos, the previous video and the same section and this video, you will be able to get clear concept about the problem on the trapezoidal section. Friends, I hope the presentation was interesting. Please go through the complete video without fail. And if you like this video, please do not forget to share with your friends. Thank you very much. Have a nice day.